Welcome to solving multi-step trigonometric equations. This is the second part after our previous lesson where we did some simple ones. So we're going to get into solving some that involve more steps or some little challenges. Before we do that though, let's review where each angle can be found. So remember, when we're talking about sine, we are talking about the y-coordinate. When we're talking about cos, we are talking about the x-coordinate on the unit circle, right? And when we're talking about tangent, we're talking about the slope. All right, so where are your y-coordinates positive, right? Your y-coordinates are positive up here and up here, somewhere in these quadrants, right? So really anywhere along here, right, is where your y-coordinates are positive. If we think about the unit circle, right, up there. Now, what I'm saying when I draw my diagram is the angle, the amount of rotation from our starting position. Remember, this is starting position right here. Here's where we start. Okay. And as we rotate to those two spots. So it could be one angle here, and there could be a second angle here, right? All right, so we're always going to start from that line. I'm just going to get rid of some of this stuff, though. All right, so why is that? Well, again, up here, it doesn't matter what the x-coordinate is. The point is when we're talking about sine, the y-coordinate is positive here, and the y-coordinate could be positive here. So remember, when we do these, the idea is the distance this way, the vertical distance and the horizontal distance are the same, right? Now, the x, one's moving negative, one's moving positive, but the y's are both moving in the positive direction upwards. So we use that when we're finding our points. Now, where are the y-coordinates negative, right? Your y-coordinates are negative down here. So when we're doing sine, these are the four coordinates we look at. Now, we look at the top if we're talking about positive. We look at the bottom if we're talking about a negative sine value. With the x-coordinates, review again from the last lesson. Where are your x-coordinates positive, right? Here and here. So when I'm dealing with cosine, I really only care about the x-coordinate. And they're there and there. Where are the x-coordinates negative? On this half, right? So you have a negative x in this quadrant and a negative x down there in the third quadrant. All right, and finally, where is tan positive and negative? Well, think about your slope. You have a positive slope when your line is heading in an upwards direction from left to right. So you have a positive slope here and here. Now, another way to think about that is because your x-coordinate and y-coordinate are both positive. And when we calculate slope, don't forget, tan is slope, which is rise over run, right? So it's sine over cos, because sine is your y-coordinate, cos is your x-coordinate, and that's how we get it. So your y divided by your x. All right, and down here, they're both negative, and a negative divided by a negative makes a positive. All right, where is your slope negative if the line is heading in this direction, down from left to right? And you can also think about it as a positive divided by a negative would give you a negative number, or a negative divided by a positive, right? So that's where we got to think about this and really keep our eye on stuff as we're doing these questions. That's really where we want to start at. Now, another way to remember this, is called the CAS system. So if these are my four quadrants, right, 1, 2, 3, and 4, they are all positive here, sine is positive here, tan is positive here, and cos is positive here. So they call it the CAS rule, C-A-S-T. So it's a way to remember where they are positive. Each of these functions is positive in two quadrants and negative in two quadrants, okay? Now, the other thing we got to remember for today is inverse functions. What is the inverse of sine? Because we're going to do those again. Remember, the inverse of sine is cosecant, and we just use CSC for short. The inverse of cosine is secant, and the inverse of tangent is cotangent. So we're going to need those to do some of today's questions, okay? All right, so in other words, if I run into a question that's cosecant, instead of using cosecant, I'm going to use sine, and I'm just going to take the reciprocal. If I run into secant, I'm just going to use cosine. Because if you look at your calculator, there's no button for cosecant, there's no button for secant, there's no button for cotangent. So you use sine, cosine, or tan, and you just do the reciprocal. And finally, don't forget that we are only interested in finding the values between 0 and 360 today. Now, there are infinite possible angles that can land at these points. Remember, what we're doing is, I'll just use sine again as an example. We are looking for the two angles, one here, right, and the other one there. Let's say it was positive, right? We don't want to find the negative angles. We could go around the negative direction like this and the negative direction like this, but we're going to look for the positive angles between 0 and 360, which generally means 2, sometimes none, we'll see, and sometimes 1, sometimes 3. So there's going to be, the previous lesson, there was usually 2, sometimes there's 1. So we commonly get 1 if we land on the axes sometimes. And we're going to run into a few of those, I think, today too. All right, so let's give this a try. All right, so don't forget, when I draw these little graphs here, really we're talking about points on the unit circle. I just don't have the circle drawn on these, but you can draw the circle or not, right? So I'll draw a circle on the first one, but I think after that, I won't bother drawing the circle again, okay? I guess that would be a little more accurate, though, to help us visualize this. All right, so right out the gate, we have secant. That is a reciprocal function. We don't have a button for secant, so we can't solve for theta when it's like that. But what we can do is take the reciprocal. So what does that mean? We're going to flip it. So in other words, let's make this reciprocal of secant is cos, right? Now, all we got to do is take the reciprocal of the other side, and that's it. So for all 3 of your reciprocal functions, you just flip it, and that's it, okay? So for example, if we had one that was like cotangent of, equals 7 or something, I would just flip this and make it tan of 1/7. Right? Or if I had, what's the other one I'm missing here? Cosecant of, let's go, I don't know, 2/3, negative 2/3. Then I would just change it to sine, flip it, and make it negative 3/2. Okay? So I'm only going to do one reciprocal function because they're all similar idea. All right, so now we're dealing with cos now. So what do we got to lock into? We're dealing with cos, so what does that mean? It means we're talking about the x-coordinate, okay? So in other words, we have an x-coordinate. And what is that x-coordinate? It is the 1/3. Okay? So that's a positive number, right? So where is x positive? Your x-coordinates are positive here and here. So in other words, on the unit circle, 1/3 is like 0.33. So remember, our radius is 1, right? So the farthest we can get is 1. So unless it's 1 or -1, right, the values are going to be between there, right? So it's going to be decimal values between -1 and +1. So 1/3, another way to write that is like 0.3 repeating, right? Now we don't really care what the y-coordinate is, just some y-coordinate. All right, so these are where your x-coordinates are positive. If this value here had been negative, I'd be looking on this side because that would mean we have a negative x value. So remember, what does this question mean? This question means, what is the angle? What angle, when I take cos of it, gives me an x-coordinate of 1/3. I'm going to write that down because this is really important to get this, start out really understanding this. So what this means is, when I take cos, right? When I take cos of what angle, right? This is not the greatest English sentence. When I take cos of the mystery angle, right? Theta, right? What angle is it that gives me, gives me, this is a terrible sentence, gives me an x-coordinate, right, of 1/3. That's what this means, but that is terribly broken English. When I take cos of theta gives me x-coordinate. Sorry, it's been a long day. All right, so the idea is when I take the cos of this angle, it's going to give me an x-coordinate, because that's what cos means, of 1/3. And like we show in our graph. So what is that angle? So what we got to do is do the inverse. So we're going to take theta, take the cos inverse of that side, take the cos inverse of this side, and we go punch in our calculator. So you know what? Let me grab my calculator here. All right, so I got my newer calculator. I don't really think it's much better. But what it wants me to do here, let me hide the tape view. I don't need, there we go. I shrunk it down a little. All right, so what we want to do is do the cos inverse. Now again, I always forget to do that. So I'm going to go, what's 1 divided by 3? What's that equal to? Right, 0.3 repeating. I'm going to do the cos inverse. So you have to hit second cos. Now mine says a cos, which is an older way of saying cos inverse. It's arc cos. On yours, it'll probably have a cos with a little -1 on it. Okay, hit that, and there we go. We're going to round everything in this unit to one decimal place to keep it simple. So we got 70.5. All right, so approximately 70.5. All right, so that's going to be my first angle. Now, it should match up with my diagram, right? Here's where 70.5 would be, right there, right? So 70.5. Now, the second angle is what we get when we travel around in the counterclockwise position to there, right? To where the second angle exists, where we already figured out where it is. Now remember, how are we going to find that? This is the same distance, like a mirror, measured from the x-axis is 70.5 in the negative direction. So to find the second angle, all we have to do is take 360 degrees and subtract that 70.5 from it. And if we do that, we get approximately 289.5 degrees. All right, so there's your two angles. Now, when you're doing your work, I want you to make sure you, at the end, state your angles, because when we get more complex, as they get harder and harder, there's going to be a little extra rough work. So what I want you to do is, at the end, state a final answer. What are my final angles? My 1, my 2, my whatever. All right, so here they are, and we drew a little picture to go with it, okay? And that's what I'm looking for. And that's what you really need to practice. All right, let's do some more. All right, so this next one requires some simplification. We need to isolate the theta. And to do that, what we really need to focus on is let's isolate sine theta. Okay, so let's get sine theta all alone. So what am I going to do first? I'm going to subtract 5. So I have 2 sine theta. This is just a linear equation, essentially, the steps we're doing, right? Minus 5. And then divide both sides by 2, right? So sine theta equals 4 minus 5 is -1. Divide by 2. Now we've isolated it. All right, now before I actually punch in my calculator, and I know I said earlier it's like a linear equation. It's not, because it's got sine in it, right? So it's a trigonometric equation. But the steps we took were similar to like when we learned how to solve a linear equation. What did I do? I subtracted 5 divided by 2, right? Okay, so we need to figure out, this basically means the y-coordinate, right? Sine is telling us what is the y-coordinate, what is the angle, right? What angle gives us a y-coordinate of -1/2? That's what that means, right? What angle gives us a y-coordinate? So the y-coordinate is negative, right? That is the y-coordinate on our unit circle. Okay, y-coordinate, oops, is negative. All right, let's put a little minus there. Now again, if you want to draw a circle on these, I used to have them drawn. I don't know why I don't have them on here anymore. You can draw the circle, or you can just, do it without the circle. Okay, so where are your y-coordinates negative? They're negative down here and down here, right, in these quadrants. So that's just back to, grade 9 graphing, right? Simple. Don't overthink it, because that's really what it is. So what I'm going to do is draw 2 lines. Now again, I'm not drawing them exactly accurately where they are. I'm just putting them in the quadrant, okay? So I don't care what the x-coordinate is. All I know is the y-coordinate is -1/2 or -0.5. Same thing over here. Don't care what the x-coordinate is. The y-coordinate is what I'm interested in. Okay. So we need to find 2 angles. One of them is going to go from here to here. The other one's going to go from here all the way to here. So again, we're always measuring counterclockwise from our starting position, okay? Now, I'll tell you right now, when we put this in the calculator, it's going to give us this angle. The calculator is going to basically spit out the fastest, closest angle to the closest one to our starting position here, okay? So it's always going to spit that out. Now, it's going to give us a negative when we do this. What we need to do is reverse that and look the other way around and figure out what the positive angles would be. All right, so you take theta, you do the sine inverse of that, right, of -1/2, and this is one of our special key points on our unit circle, so this is going to be -30 degrees. All right, so right here is -30, right? So it did point at the right place. We drew an angle down here, and that's where it should be. So it matches up with what we thought, but we need to find the positive. So now, don't forget, from here to here, like a mirror, is also 30 or -30, whatever you want to think. The idea is it's 30. Forget, the negative is just telling us the direction. I'm concerned about the angle. All right, so how are we going to find these 2 angles? Let me get rid of this stuff, right? Oops. All right. Oh boy, I'm really wrecking it. I'm gonna just leave those in. All right. So the first angle from here to here is 180 plus 30 more, right, would bring us to there. So angle 1, we're going to go, what's 180 plus 30? Boom, 210 degrees. All right. What about angle 2? Well, angle 2 goes all the way around here, 180, 270, and then a bit more, and it stops there, right? Well, again, all we got to do is go, it's 30 degrees back from a full circle. So we just need to say, what's 360 minus that 30 degrees? And we'll get the 2 positive angles between 0 and 360. All right, so remember, it's not wrong to say that -30 arrives at that terminal point, right? That's the terminal point being these points here, right? But we want to find the 2 positives, okay? So our final answer, just make sure you write them out, 210 or 330 degrees. There you go. Okay, include your little sketch. So that's kind of the work we're looking for here. All right, let's do a few more. We're going to do about 4 more. Each one's going to have a little bigger challenge than the last. Okay, we got one involving tan here, and like the previous one, it also requires simplification. So we need to get the 2 terms that involve tan to the same side, these 2, right? Oops, I just noticed a typo. Just this 7 wasn't supposed to be there, sorry. Because if I make it 7 tan, the tans will cancel out and we got nothing. That was just a typo. All right, so let's just erase that off our page. There we go. Typo by me. This is a better question now. All right, so what we're going to do is collect the tans. So we have 7 tan theta, and we're going to subtract this tan theta off this side and subtract 1 tan theta. Now, I don't have the coefficient written out front. If you want to write a 1 out front, you can, but we don't need it. Equals 2 times root 3. All right, so 7 minus 1, you now have 6 tan theta, and you're going to divide both sides by 6, right? And that 2 over 6 we can reduce to root 3 over 3. So I just reduced it all in one step. All right, now, before I find tan inverse, let's recognize this is tan is our slope, right? So let's not forget. Again, I know I'm repeating it a lot, but tan is the slope. And the slope is a positive number, right? How do I look at this number right here is what we're talking about. So what does this mean? This basically means what angle gives me a slope, that's what tan means, that is positive root 3 over 3. We're looking for the angle that gives that positive slope. That's what we're looking for when we're talking about tan. And these are the things I'm trying to kind of, I guess, hammer into your brain, right? Tan is slope. Tan is slope, okay? So one more time, right? What angle gives me a slope, that's what tan means, of positive root 3 over 3. All right, so where do we have a positive slope? Well, we have a positive slope. If this, let me draw our circle on here again. Oops, oh boy. Really fun watching me goof around with the computer here, I know. All right, so, here's my circle, my unit circle, right? It's a little off, but it'll have to do. All right, so when do you have a positive slope? Going through 0, 0, right? Well, this is what the line would look like. Now, it could be more tilted or curved, not curved, sorry. It could be, less steep or more steep, but it has to go through 0, 0, okay? So there. So it's going to hit here and here. Those are going to be the points it hits. Now, we don't know the points. We just know right now what the slope is, all right? So what we're going to do is take the tan inverse, right? So let's do that. Tan inverse, and we got a button like for that on our calculator, root 3 over 3. I already got it calculated to save us time. It actually is exactly 30 degrees. All right, does that match what we have on our graph? Yes, look, there is 30 degrees, right? 30 degrees is in the first quadrant. Now, obviously, I've drawn mine a little too steep. The line should have been a little more like this, right? But we don't have to be accurate on our diagram, just show what quadrant we're in. Now, don't forget, that means this is also 30 degrees from the x-axis. There you go. All right, so we already know the first angle. Angle 1, because it's positive 30, it didn't give us a negative, that's one of our angles, right? Now, angle 2, how are we going to find that? So this is angle 1 right here. Angle 2 goes 180 degrees plus 30 more to get to there. So what's 180 plus 30? Boom, 210, done. So I know I don't know if I'm making this look easy or not. It's not super difficult if you draw the diagram, okay? Because the diagram tells you exactly where that angle should be and measured from the x-axis. So taking your time and doing a neat job. And when I was your age, I didn't always do that. And as I got older, I realized, oh, that's why I had trouble. I shortcutted everything. And sometimes in the shortcuts, I would miss something and I could never see what it was, obviously because of the shortcuts, okay? All right, let's move right over and check out the one next to it here. This is another one that requires some more simplification. It's kind of getting to be a little bit of the same idea. Let me just move this up just a titch. All right, so what we need to do first is distribute. Distribute the 3, distribute the 3, right? Collect like terms, that's all we're doing. 3 sine theta plus 6 equals 3 minus sine theta plus 2. I'm writing these in capitals, but just so you know, that's like a mathematics sin. I'm not trying to be funny, the word sin there. You're supposed to write trig functions in lowercase. I have a bad habit of writing everything in uppercase, so I'm sorry. That is one part. You might have some math teacher really crush you one day on that, and they are right and I am wrong. All right, so 3 sine theta plus 1 sine theta, right, is 4 sine theta. 3 plus 2 is 5, minus 6, we got negative 1. Divide both sides by 4, we got sine theta equals negative 1/4. All right, so again, what does this mean? It means sine tells us what's the y-coordinate, right? Well, the y-coordinate is negative 1/4. So what this means is, what's the angle when your y-coordinate is negative 1/4? Okay, so the y-coordinate is negative. Where are your y-coordinates negative? I'm not going to draw the circle this time. I'll just say it's down here, right? Down here and here on my circle. All right, so what the calculator is probably going to give us again is the negative angle here, because it wants to give us the shortest distance, the quickest way to get to the closest angle. That's what the calculator spits out. Okay, so it's going to spit that one out. It's not going to give us the positive one because this is a lot longer distance to get to there, and it's definitely not going to give us this one. Okay, so the calculator is going to give you a negative angle here. So if you do theta equals the sine inverse of -1/4, you are going to get, I already calculated here, -14.5 approximately. All right, so that's what that is right there, -14.5 degrees. Now symmetrically, this is also 14.5 degrees down from the x-axis. All right, so to find our two angles, it's pretty simple. We start at starting position here, right? And the first one is going to be from here to here. Okay, so angle 1 is going to be 180 plus 14.5 degrees more, right? So that's going to give us 194.5 degrees. And angle 2 is going to be all the way around. We've seen one like this already. This is just 14.5 more to get to 360. So all I got to do is subtract 14.5 from 360. All right. And there you go. And what's that going to be? 345.5 degrees. All right. So there's our final answer. Make your final answer really clear to me, please. Put a box around it, you know, write them out. You've shown all your work here. Beautiful. There it is. All right, cool. All right, let's do 2 more. All right, so now we have one involving an exponent on the function. I can't remember if we've talked about this before. So many lessons, so many classes, but when you write the exponent on the function, you actually write it right on the function name. So think about it. Oops. Here we go. So think about how this could cause confusion, right? Let's say you want to do the sine. Let's just use a number here, like sine of 45 degrees, okay? Well, if I write the square there, now is the square on the 45, is it 45 squared or is it sine 45 squared, right? That's where it's a problem. It's ambiguous like that. So if we want to square the whole function, we either have to write it like this, okay? Oops, sine 45 degrees squared. So that would mean the whole function squared. I'd find sine of 45 first and then square it. Or the more common way is to just put the square on the sine itself, on the function name. So that actually means finding the sine of 45 and then squaring it, okay? So if we don't have, if technically this is saying that the 45 is squared there. All right, so just keep that in mind as we check these out. All right, so first thing we got to do is isolate the sine function, right? So we have sine squared theta. We're going to subtract the 4, or sorry, add the 4 to the other side. We're going to divide by 8, right? So we're going to have sine squared theta equals 7 over 8. Now, here's where it's going to get a little messy. We have to take the square root, right? So sine theta, take the square of that side, eliminates that. And remember, we could have a positive or a negative value of 7 over 8 squared. So what this tells us is the y-coordinate could be positive or negative, okay? So we're going to have to break this up into 2 questions, basically. Could be positive or negative. So how many angles could we possibly get to, right? Think about that. If we've been getting 2 angles for most of these every time, that means there could be 4 possible angles, okay? All right, so let's check this out. So what I'm going to do is I'm actually going to make a second diagram. I'm going to take a copy of this here. There we go. I'm going to put a second graph. All right, let's do 2 of them, okay? Let's do one where sine is positive. All right, so I'm going to write sine positive. Okay. And we'll do another one down here where sine is negative. All right, now they basically go the same, and sometimes you get the same values. You'll find it's just positive or negative value as you experiment with these and learn about them. Okay, so in the positive case, right, what we're going to do is take the sine inverse of positive. I'll just write the positive in front just to make it clear. Square root of 7 over 8. In the negative one, we're going to do sine inverse of negative square root 7 over 8. All right, now I've already calculated this, and what you basically get, I punch in my calculator, you know, what's 7 divided by 8, take the square root of that, and then do the sine inverse of that. Oh, I forgot the inverse, see? All right, there we go. And when I do the positive one, I get 69.3 degrees. When you do the negative one, guess what? You get negative 69.3 degrees. So far we got 2 possible angles. Now, let's look at our diagram. Maybe I should have started with that also, right? Where is sine positive? When we're talking about where's the y-coordinate positive? The y-coordinate positive up here and here. Oops, oh, that's a pretty terrible line. All right, when we look at this one, where's the y-coordinate negative? Down here and here. All right, so I'm going to draw that first angle on. 69.3, yep, it matches right there, right? That's where that would be. Negative 69.3 from our starting position, yep, that's exactly where it would be. All right, now we need to find all 4 angles. We already have one of them. This angle is good. He's positive, right? We were looking for the positive angles. So there's our first one from there to there. How are we going to find the second one from starting position to there? Well, remember, this is the same distance from the x-axis. It's also 69.3, just backwards. So all I got to do, I'll just call this angle 2 here, is I just need to go, what is 180 minus 69.3 degrees? All right, so that angle is going to be 110.7 degrees. So that's what this guy is here, all the way to there, 110.7. All right, so we've got two angles. Now, we need to find angle, I'll just call them 3 and 4. Angle 3. Well, again, we don't want the negative, but we know distance-wise that this is also 69.3 right here, right? All right, so they're both 69.3. So measuring from here to here is 180 plus 69.3 more. I just got to add that to 180. So notice all I'm generally doing with when I'm finding the other angles is usually I'm adding or subtracting from 180 or subtracting from 360, right? That's all I've done so far when I find the other angles. All right, so let's add that. Sorry, my bad. And that's going to give us 249.3 degrees. All right, how are we going to find angle 4? Well, from here to here, right, all the way around to stopping there, that's just 69.3 degrees away from 360. So all we got to do is go, what's 360 minus that? I'm sure some of you have been predicting that now. You're kind of getting the flow and feel of this. Gives us 290.7 degrees. All right, so there's all our angles. Let's just write them all out at the end. All right, so theta could be equal to 69.3 degrees, or 110.7 degrees, or 249.3 degrees, or 290? Yeah, 290.7 degrees. So why do we have so many again? Let's just review, right? Remember, in this question, we're basically looking for what angle makes this statement true, right? So when we got down to here, we said what angle, right, will give us a y coordinate, that's what sine means, that could be positive or negative square root of 7 over 8. And that's from our diagrams, 4 possible angles, okay? All right, one final example. All right, let's do one more. I got 2 graphs already kind of ready to go here. This is the actual question, okay? 2 cos squared theta minus 7 cos theta plus 3 equals 0. Now what I've done next to it is I've written it out, but I've replaced the cos thetas, or cos squared theta, or no, cos theta, sorry, with just x's. Look at this. What if I told you to solve this one here? You would just factor it, right? So that, or you could use the quadratic formula, and we could use it with this one too, but I'm just going to factor this thing, okay? So it's the same thing. These are basically the same. It's just I've just let x equal cos theta. Okay? So it's the same idea. So what I'm trying to show you is if you can factor the first, you can factor the second one here. So let's factor. So I need 2 numbers that multiply to make positive 6, that add to make negative 7. Well, that's going to be negative 6 and negative 1. 2x squared minus 6x minus 1x plus 3 equals 0. All right, let's common factor out of each group. I'm going to common factor 2x. So I'm using decomposition here. If you don't like decomposition, you can use any method you want to factor. You can even use the quadratic formula, right? All right, x minus 3 equals 0. And now I can common factor out of each group x minus 3 and 2x minus 1 equals 0, right? And you can even do this if it helps you. So now think about it. X minus 3 has to equal 0, so x has to equal 3. Or 2x minus 1 has to equal 0, so x has to equal 1/2, right? So that would be my 2 solutions here. Well, it's the same thing over here. After we factor this, I won't go through all the steps because it's the same steps. You're going to end up right here with cos theta minus 3 and 2 cos theta minus 1 equals 0. It's the same thing. Now we could do you could do all these steps if you want. You'd just be replacing the x's with cos, right? Exact same thing. So guess what we have here? Cos theta minus 3 has to equal 0. So that means cos theta has to equal 3. So that's one of our possible answers, right? The other one, 2 cos theta minus 1 has to equal 0. So you're going to add 1, divide by 2. You're going to get cos theta equals 1/2. All right, so let's think about this. We have 2 possibilities, right? Now in both cases, it's cos, which means it's the x-coordinate, x-coordinate, x-coordinate. And in both cases, we have a positive x-coordinate, right? So the one, where's x positive? Here or here, right? And here and here. So I got 2 possibilities that are set the same. Now, watch what happens. If you do, you know what, I'll just tell you what happens instead of boring you with all the calculator button pushing. But if I do this, if you go cos inverse of this first one here, of 3, you get an error in your calculator. It says error. Why does it say error, right? Doesn't make sense, right? Well, we have a number, we did cos inverse. Remember, this number here is the x coordinate on the unit circle. And what's the problem with that? The problem is what's the largest number and the smallest number you can get for sine and cos on the unit circle, okay? The biggest you can get is 1. So if I have a unit circle here, let me just draw a really quick, crappy circle. Here's my circle, right? The farthest we get is 1. So x is positive 1 right here, right? 1 over and y is 0 up, and it's negative 1 over here. Your x-coordinate's negative 1, y is 0. So you can't have a number greater than 1. So the calculator's basically saying, I can't calculate this. There is no possible angle, right? There's no angle that will gives an x-coordinate that's equal to 3. It's impossible. So all our x-coordinates and y-coordinates all are between negative 1 and 1. That's why we're getting some of these decimal numbers, right? It gives an x-coordinate equal to 3. So that's the problem. Okay, so the good news is there's nothing to solve for this first one, right? There's no solution for this. Now, if that was the only one we had to solve, we would just say no solution and move on, all right? But we can still solve the other one. This number is okay, right? That's positive 1/2, 0.5. So let's take the cos inverse of that. Cos inverse of 0.5, punch it in your calculator, and you get exactly 60 degrees. So right there is where that 60 is. How are we going to find the other angle? Remember, it's 60 backwards from the x-axis. So all we're going to do is measure around from here to here. So there's angle 1. How are we going to find angle 2? Right? We're just going to go 360 minus 60, which is 300 degrees. So in the end, we only have 2 solutions. We had a possibility of getting 4, but we only ended up with 2. So our final answer is 60 degrees or 300 degrees. Okay? All right, so give these a try. Ask questions if you got them. All right. And feel free to ask online. I'm sure you'll have some trouble with some of these. So totally throw them out there on our EDSB page or message me, whatever you want, and I'll help you solve these, okay?